Alright, welcome. In this video, I'm going to be working a few more related rates problems, and this is going to be quiz 4.4 versions M and N. So the first one, these are going to be some cones and some shadows, and then I think some other stuff on there too, just kind of getting you practicing all of Unit 4. Okay, so we've got water draining from a cone. So the cone is the container, and so we're going to need to use that similarity relationship. We can also see that in the diagram. We've got those two similar triangles. Okay, the container is in the shape of the cone with radius 12 and height 48. At what rate in centimeters per minute is the radius of the surface of the water decreasing? All right, so I think that's going to be important for us to be like, okay, I'm looking for dr dt. I didn't write this on there, but had I given this quiz in class, I would have needed to give you the formula for the volume of a cone. That's 1/3 pi radius squared times the height. That's not something you're expected to know in AP Calculus. Okay, but we're going to need to use the similarity relationship. We know that the ratio of radius to height at any point in the when the water is filling up the cone or draining from the cone is going to be 12/48, which is 1/4. Now, if I want dr dt, I need to have r in my formula for volume. So I'm going to need to be solving for h. So I'm going to say r equals 1/4 of h, and then multiply both sides by 4, and h would equal 4 times r. All right, so I'm going to make that substitution. I'm going to say v is 1/3 pi radius squared multiplied by height, which is 4r. And so if I put this all together, okay, volume is 4 pi over 3 times radius cubed. And then if I take the derivative with respect to time, I'll have dv dt equaling 4 pi r squared dr dt. Okay, so I should be able to plug in what I've got and solve for what I need at this point. Okay, so we said the radius is 5 centimeters, so that's 4 times pi times r squared is 25. dr dt is equal to dv dt, and so draining 10 cubic centimeters per minute, so that's -10. Okay, and then I can solve for dr dt and say that's going to be -10 over 4 times 25 is 100 pi. And if you wanted to simplify that and call that -1/10 pi, you'd be welcome to, but I'm just going to leave that there. All right, a conveyor belt is dumping sand onto a pile at a rate of pi cubic centimeters per minute. The pile is in the shape of a cone with radius and height that are increasing over time, but maybe not necessarily staying the exact same shape of cone. When the safety inspector arrives on the scene, the pile has a height of 3 meters, a radius of 3 meters, and the radius of the pile is increasing 1/24 of a meter per minute. What rate in meters per minute is the height of the pile increasing? Right, so we're going to start with the same idea. Volume equals 1/3 pi radius squared multiplied by the height. But this time we don't have any similarity relationship, so we just have to take the derivative using the product rule. So I'm going to look at this as the product of 1/3 pi r squared and h. So first I'm going to take the derivative of 1/3 pi r squared, and I'd get 2/3 pi r to the first dr dt for the chain rule. Leave h the same. Then I'll add, leaving 1/3 pi r squared the same, multiplying by the derivative of h. And I think at this point I should be able to just like plug in and get what I need. Okay, the pile has a height. I feel like, okay, yeah, it's dumping sand onto the pile at a rate of pi cubic centimeters per minute. That's the very beginning. So that means that dv dt, that's going to be pi. So I'm going to say pi is equal to 2/3 of pi. I'm just going to call that 2 pi over 3. R is 3. dr dt is 1/24. And h is also 3. All right, and then plus 1/3 pi radius squared is going to be 9, and dh dt is the thing that we're interested in eventually finding. All right, so I think it would be beneficial at this point to divide both sides of the equation by pi. I can see that each term I'm adding together right there, and each term in the equation has a pi in it, so I can just divide by pi, and just 1 is, okay, so let's see, 2, these 3's will cancel. 6 over 24 is 1/4. Yes, and I've already lost the pi's, so I've got 1/4 plus 3 dH dt. Then I'm going to say, all right, I'll subtract 1/4 from both sides. 3/4 is equal to 3 times dH dt, and that's telling me that dH dt, that's going to need to equal 1/4. Right, the next one's talking about a 0.5 meter tall cat running away from a 5 meter tall street lamp at a rate of 18 meters per second. All right, so this one we need to draw the triangle. So I'm going to just draw in kind of a line there and hope for the best. Yeah, that'll work. And then I'm going to just say, all right, that's be my other part of the triangle there. That didn't go all the way. Let me try that again. There we go. Yeah, perfect. Okay. So, and then I'm going to label the triangle with what they're telling me. So the street lamp is 5 meters tall. The cat is 1/2 meter tall. And it's running away at 18 meters per second. All right, so I'm going to call the distance from the lamp to the cat x. And they're telling me that dx dt is positive 18 because the distance is increasing. It's running away from the lamp. Okay, but then I'm going to need to say, okay, well, it's got a shadow also. And I'm going to say, all right, the shadow is, this. And I'm going to call that w. I'm going to set up a proportion. 0.5 over w is going to equal 5 over x plus w, because it's the whole triangle. Okay, then I cross multiply. Simplify the equation. 4.5 w equals 0.5x. At this point, you could even multiply both sides by 2 if you liked, and say 9w equals 1x, and then you could take the derivative of both sides. It really doesn't matter. 9 times dw dt is going to equal 1 dx dt. Right, and they told us that dx dt is equal to 18, so 9 times dw dt equals 18. So that must mean, okay, we're looking for the rate of change of the shadow length, so that's dw dt. It's going to need to equal 2. So it's going to be 2 meters per second. His shadow is lengthening. All right, now, number 4 and 5 is going back to the differential equation. This has nothing to do with related rates, but I thought it would be good practice for you. So if y equals f of x is the particular solution to this differential equation with f of 5 equals 3, use a tangent line to estimate the value of 5.03. So we're going to need a point and a slope to write the equation of our tangent lines. The point's going to be 5 and 3. Slope we'll get from dy dx. So at the point 5 and 3, dy dx equals 5 squared is 25 minus y to the 3 is going to be 27, so that equals -2. Okay, so my equation is going to be y minus 3 is equal to -2 times x minus 5. We're going to approximate the value of f of 5.03, so I'm going to say my approximation is f of 5.03 is about equal to 3 minus 2 times 5.03 minus 5. Now, for the quiz, or for your response, we're good to stop there. But, this is oftentimes multiple choice, and so I'm going to simplify this just so that, you see we need to get the practice. Okay, so 3 minus 0.6. Wait, that's a very easy mistake to make. 3 minus 6 cents would be 2.94. So I think that's worth practicing. All right, if g is the particular solution to the differential equation up above with g of -8 equals 4, is there a maximum, a minimum, or neither at x equals -8? All right, so I'm going to try dy dx at -8 and 4. If it comes back non-zero, I'll know it's neither. But if it comes back 0, I'll need to check the second derivative. So that's going to be x squared. That's positive 64 minus y to the 3. 4 to the third is 64. Okay, that's 0. Okay, so I have a potential extremum. Okay, and in this scenario, it's going to be an extremum because if I got second derivative 0, I wouldn't really know what to do, and they're always going to lead you towards a definitive answer. All right, so I need the second derivative. So I'm going to take the derivative of dy dx implicitly and get the derivative of 2x, or the derivative of x squared is 2x, minus the derivative of y to the 3 is going to be 3y to the 2 dy dx. Right, then I'm going to plug in -8 and 4. I'm going to get 2x minus 3y squared dy dx. That's going to be -16, which is a less than 0 number. Since the first derivative is 0 and the second derivative is negative, I can conclude I am at a local maximum. All right, and number 6, a scientist is watching a rocket launch from a safe distance of 3 kilometers. The rocket is moving with velocity 2 kilometers per second when its altitude is 4. So I've got an altitude of 4 here. Safe distance is 3. That means I've got a 3, 4, 5 triangle. That's nice. And the rocket, okay, so I'm going to say that's y, 3 is x, and 5 is r in case... let me think about this. Okay, so at what rate in radians per second, so I've got theta here, is the angle of elevation from the scientist to the rocket changing when the altitude of the rocket is 2? Okay, that must be a mistake. I think that must have been, yeah, that needs to be altitude is 4, because that's the only time I know about. Okay, didn't catch that. I don't think we went through this one in class. All right, so I need, what's changing? Y is changing. X is not changing. R is going to be changing. Yeah, so my options would be to use like sine. I could use sine of theta would be y over r. But both y and r are going to change. But if the scientist isn't moving, then the x is going to stay the same. So I'm going to use tangent. You say tangent theta equals y over x. But in that case, x is fixed, so I'm going to substitute on that and say it's y over 3. Okay, yeah. And I think actually a better way to write this for us to take the derivative is going to be 1/3 of y. And then I'll take the derivative of both sides. Secant squared theta d theta dt is equal to 1/3 of dy dt. They told us in the statement of the question, yeah, 2 kilometers per second. So that's going to be dy dt. So dy dt is 2. So I'm going to say, all right, maybe I'll multiply both sides by cosine squared t to get rid of that secant squared t, or, look at the secant squared t as 1 over cosine squared t. Either way, I'm going to say that's 1/3 times dy dt, which is 2 times cosine squared theta. Right, and we know what cosine is. That's going to be 3/5, right? Because it's going to be a 3, 4, 5 triangle. So d theta dt equals 2/3 times 3/5 squared. So times 3/5 times 3/5. And that's going to be, get rid of those, 6 over 25. Okay, and that's all for Form M. All right, on Form N, it's very similar, so I'm gonna go through this one a little faster. We've got our volume formula. We know that the ratio of radius to height on this cone is 12 to 48, or 1 to 4. And we're interested in the rate of change of height So I need to get rid of r. I need to keep h in my formula, so when I take the derivative, I have a dh dt. So I need to get rid of r. So r is going to be 1/4 of h. And so when I plug in there, I'm going to say, all right, well, that's 1/3 pi. Radius is 1/4 of the height. The squared multiplied by the height. So if I combine this, all 1/4 squared is 1/16. I'll have pi. 3 times 16 is 48. And 3 total powers of h. So I can take the derivative of volume with respect to time and get 3 pi over 48, which would be 1 pi over 16. And it actually might have made sense to leave the denominator unsimplified as 3 times 16. If it's not like arithmetic you're super good at, then you would have ended up canceling it off anyway. Pi over 16, h to the 2 dh dt for the chain rule. Then I'm going to plug in dv dt, the value they gave me, that was 10. Pi over 16 h squared. Okay, what is h gonna be? Okay, the radius is 5. As a result, that means that the height needs to be 20. Okay, so radius equals 5. 5 equals 1/4 of the height. Height has to be 20. All right, so h squared is going to be 400 times dh dt. So what's going to happen is I'm going to multiply both sides by 16, and I'll get 160. And then I'll divide both sides by pi and by 400, so I'd have 400 pi. Well, that is dh dt. If I was going to simplify that, I could definitely divide both sides by 10, at least. 16 over 40 pi. I see there's a factor of 8 in both of those, so that's probably going to be 2 over 5 pi. I'm pretty sure about that. Yeah, that looks good to me. All right, conveyor belt dumping sand onto a pile. Same story here. We're going to take the volume formula, but we're going to have to take the derivative of this one using the product rule because there's no similarity relationship. So I do that, and I plug in the information I've been given. The conveyor belt's dumping sand onto the pile at a rate of pi, so that's dv dt. 2/3 of pi multiplied by the radius, which is 6. dr dt is unknown. That's what I'm hoping to find eventually. H was also 6. Okay, and then I'm going to add 1/3 of pi multiplied by radius squared. Well, radius squared is going to be 36. And dh dt, and they told me that dh dt is 1/15. All right, so this is going to be kind of rough on the simplification front, it feels like. Okay, but it'll be all right. So I think first thing, I'm going to divide both sides by pi. So I'm going to get rid of all of this. And then I'll have 1 equaling, all right, well, if I have 6 over 3, that's going to be 2. Maybe I'll do some of this simplification in red. And then 36 over 3, that's 12 over 1. But wait, 12 and 15, that's like 4 and 5, right? Yeah. Divide both sides by 3. All right, so now I've done some simplification here. I've got 2 times 2 is 4, times 6 is 24. I do not remember this happening when I worked this one in class, but I must have done something wrong, or maybe I've done something wrong now, who knows. Plus 4/5. So, who knows? I think now I would subtract 4/5 from both sides. If I've made an error, please come let me know or something. 1/5 equals 24 of dr dt. And as a result, dr dt is going to be 1/5 times 24, which would be 1/120 feet per minute. Right. Another shadow walking type question. Ended up looking pretty good. Okay, got the cat there, and we're gonna label. Okay, so it says the street lamp's 2 meters tall, the cat's half a meter. Okay, we're gonna label the distance x and the shadow w. Proportionality relationship is that, the vertical leg to the horizontal leg on the small triangle is going to be equal to the vertical leg to the horizontal leg on the big triangle, because they're proportional. And then I'm going to cross multiply to w equals 0.5x plus 0.5w. Simplify a little bit. Maybe multiply both sides by 2. I did not do this in class, but I kind of like this idea. Take the derivative, 3 dw dt equals dx dt. Figure out, what did they even give me? The length of the shadow is increasing at a rate of 2 meters per second. So they gave me that dw dt was equal to 2. So that's going to be 3 times 2 equals dx dt. That's how fast he's running, how fast the distance between the cat and the lamp is increasing. So that would be 3 times 2 is going to be 6 meters per second. All right. X squared minus y to the third. This is exactly like the other form, except I think I asked a different question on the back, or on the second part. I didn't ask about the maximum and minimum. I asked overestimate or underestimate. So that's why it would be a good idea for you as you're reviewing to do both of these forms. Okay, because it's a little more comprehensive that way. So x squared minus y to the third, tangent line, 0.5 and 3. Slope dy dx at the point 5 and 3 is going to be equal to 5 squared minus y to the third. And so it's 3 to the third is 27. I've got a slope negative 2. Okay, the equation is going to be y minus 3 equals not 5, negative 2 times x minus 5. So then the approximation is going to be, let's say, f of 4.98 is going to be approximately equal to 3 minus 2 times 4.98 minus 5. Okay, and I'm going to simplify this. Negative 0.02, so if I'm subtracting 2 of those, I'd be adding 4 cents, so that's 3.04. Right, and then we're going to find the second derivative of y with respect to x both times, and I'm going to find it in terms of x and y only, because that's usually the prompt. And if f prime is negative for all x in the interval 4.98 to 5... Oh, I see why that's going to be... Okay, anyway, find second derivative. So I'm going to take the derivative of dy dx implicitly. I feel like that's a typing error, but I know I'd kind of like borrowed this from a recent free response problem. So I take the derivative implicitly, 2x minus 3y squared dy dx. Okay, now on the interval 4.9 to 8 to 5, it's going to have to be the case that 2x oh wait, why would that be the case? Okay, then we're going to need to do a little more investigation here. Okay, let's just investigate the value of the second derivative at the point, which at this point in the course is going to be enough for my class, but in the long run, we're going to need the analysis of on the entire interval. So this is at the point 3 and 5. And so this is going to be 2x is 6 minus 3 times 25 times, okay, I see, dy dx. So as long as this is like a positive number, that's not like, oh, no, if f prime is always negative, oh, okay. Yeah, then the second derivative is always going to be positive. I get it. I did not look at that closely because f prime is less than 0. In fact, I'm going to highlighter that. That means this thing is a negative number. As a result, the whole thing is positive. And so, yeah, that means that the second derivative is negative. I was like, what is going on here? This is greater than 0 because dy dx was negative 2. This is going to be positive. As a result, f is concave up, which really is not relevant to my justification. I'm just using it to remind myself that I draw that, and a tangent line sits under the curve, so I did an underestimate. There was something to that f prime less than 0. Underestimate. All right, and now the last one is going to be the scientist watching the rocket launch, and we're going to say, all right, we're interested in, okay, they gave us theta. How fast is the rocket climbing? What's dy dt? Okay, so y is going to equal something, x is going to equal something, and r is going to equal something. We're interested in what's fixed, and I think what's fixed here is the distance from the scientist to the rocket, the 3 kilometers. Altitude is 4. Angle of okay, that means r is equal to 5. Okay, but r is going to be subject to change as well. So I don't think it really much matters. We really are going to want to use x because it's fixed, and we're going to need to use y because it's the thing I'm looking for its derivative, so I'm going to need to use tangent again. So, and they told us that d theta dt equals 0.3. Alright, so I'm going to use tangent. Tangent of theta is y over x, but x is always 3, so it's going to be y over 3, or 1/3 of y. Take the derivative of both sides. dy dt. dy dt is what I'm hoping to solve for eventually, so I'm going to just multiply both sides by 3. Okay, and now I'm going to say, all right, I have d theta dt, I just need secant squared theta. So that's 1 over cosine squared theta, and this, I think this is a good time in the course for us to like kind of remind ourselves of what that means. That means we take cosine theta and then we square it. All right, so in this case, cosine of theta is equal to adjacent over hypotenuse, 3 over 5. So that's 1 over 3/5 is 5/3. But then I'm squaring it. That's going to be 25 over 9. All right, so I've got 3 times 25 over 9 times d theta dt is 0.3, which I'm going to call 3/10. Okay, so I'm going to cancel off some stuff. 3 times 3 is 9, divided by 9 is 1, 25 divided by 10 is going to equal 2.5. Okay, and that's it for this quiz. That's going to be all for this video. Thanks for watching.